Welcome to The Green Fix. In this podcast, we explore how businesses are navigating a changing world through the lens of supply chains, sustainability, and tech.
Welcome to The Green Fix. We're very excited to have Hudson Worsley join us today from MECLA. Hudson, welcome to the podcast.
G'day, Dan. Hi, Loretto. Thanks for having me.
So can you explain to the listener what MECLA and what embodied carbon is? And specifically to the construction industry, why is it so important?
Sure. So the first thing is to say MECLA is an acronym for Materials and Embodied Carbon Leaders Alliance. It's an initiative that I helped set up with WWF 5 years ago. The wonderful Monica Richter. Monica said to my business partner and me, hey, embodied carbon is the next thing. So we did some foundation research, and the conversations with 30 odd participants across construction and infrastructure to ask, are you thinking about embodied carbon? And we kept hearing, look, we want to do something about it. It matters. It's a missing piece on the path to sustainability, to circularity, but we can't do it on our own. Embodied carbon refers to the emissions generated for a material before or as it is used. So the mining of iron ore, the processing of that into iron, the processing of that into steel, the working of that into a girder or a Rio bar, the transport of that to site, the welding on site, and there it is. That's all upfront carbon and embodied in that material. So if you're going to account for the carbon of that piece of steel reinforcement that sits within a piece of structural concrete, then all of those numbers add up. The whole life embodied carbon also refers to what happens to it at deconstruction. But most of our conversation happens before that because it's not in the control of the constructors. But holistic thinking, we reference it and recognize it. And, the making of materials, concrete, it is the most ubiquitous construction material we have. Per weight, it's actually not the most carbon intensive. Steel is much more intensive, but we just use so much of it. And we've been using it since the Roman times. So we've been using it for a long time, and cumulatively, it adds up to about 8% of global emissions. If it was a country, it would be the fourth largest emitting country in the world. If you add steel to that, you're dealing with bloody big numbers. And so the Green Building Council has been going for 25 years looking at operational performance, and rightly so, because that's easily measurable. It's actually solvable through efficiency. There are good price signals to justify investment in savings and improvements as well. And generally, a well-managed building is a nicer place to be. The air quality is better, the temperatures are right, the lighting's good. If you go into a building that's low embodied carbon, you're not going to notice the difference because the materials are still look and feel very similar, if not the same. So the challenge is it's been out of sight, out of mind, and it hasn't really been measured. Let's address that. ThinkStep ANZ, one of the terrific consultancies out there, did some work with Green Building Council. In rough figures, at the moment, 15% of a building's life cycle emissions are embodied carbon and 85% are operational. Let's flip to 2050 as the grid decarbonises. If we don't act on embodied carbon, those numbers will be reversed. Only 15% of emissions will be operational and 85% will be upfront. That's the challenge. And we keep building. If buildings are fully electrified, if they stop using fossil methane, if they stop using diesel deliveries, they use renewable electricity through the grid and on site, then the remaining impact of that building will be the carbon that's gone into the materials to build it. That's what we're talking about.
And what would you say is the state of reporting for Australian building industries? Are most buildings created today? Do we know what their embodied carbon is, or is there some gap there as well?
Terrific question. There are a lot of gaps there, but if a building owner or developer or government infrastructure entity, if the leader of the decision process for the building of that building wants the number, they can get it. And to a pretty good level of accuracy. But do the majority of buildings do that? Absolutely not. And so the capability is there. The concept of digital twins is a fantastically powerful engineering technology tool that says, here's Tower A, and that uses all of the standard construction methodologies, standard materials, And the QS, quantity surveyor, can tickle their keys and come up with the answer. All right, let's use lower emission materials. Let's use electric arc steel, electric arc recycled steel, Let's use a lower emission cement in the concrete mix. Let's use green aluminium in the facade. Let's minimize truck movements to reduce the transport emissions and so on. They can come up with business as usual, base case, and then the actuals. Well, they can come up with the design, the as built, as designed numbers. And then hopefully the project team has also been recording data of as delivered, because as designed isn't always as built. I think we'd all accept that. And that as built number can be totted up and you can have an answer. So yeah, 3 sets of numbers: base case, as designed, and as built. Challenge, of course, is the base case, because it's not like mass production. A family SUV A versus the upgraded model. Yes, they made millions or hundreds of thousands of that one. They can compare that as a base case. If you're building a hospital, it's a one-off. If you're building a bridge, it's generally a one-off. And, it's a commercial environment. The temptation to sandbag that initial number to make it big so that the savings look better is always a risk. I'm not pointing fingers at anyone for doing that, but there's a very strong temptation to make the numbers look better. But there's a whole industry around carbon measurement, the life cycle assessment profession, the production of EPDs, environmental product declarations. There's now a variation on that called a product carbon footprint, a PCF, and that uses the same methodology for the whole EPD, just for the carbon numbers, to get to the global warming potential. An EPD is a bit like the nutrition information on the side of a box of cereal. If I were to compare the health data for a box of cornflakes versus a box of Wheat Bix, I've got pretty comparable data. How much sugar per serve, how much salt per serve, and so on. An EPD is similar. It's not a rating. It's not like the health rating, to continue that metaphor. It won't tell you this source of steel is better than that source, but it will tell you what's in that piece of steel from that source compared to another one. That's very powerful data. An EPD is rigorous. It is third-party verified, but they're expensive and they're quite laborious. There are all sorts of online tools and new market entrants improving that, but that's essentially the gold standard of how much carbon and other impacts, but we're sticking to carbon, has gone into the making and the transport of this linear metre of structural steel from BlueScope in the Illawarra.
Mm-hmm. So one thing that's really interesting is that the largest procurer of materials in Australia are our governments, our federal government, as well as our state governments. Do you think they play a big role in creating incentives for contractors, particularly down the value chain, that may change business models or change that part of the economy?
Absolutely. 5 years ago, one of the top 5 findings from our foundation research was government procurement is the biggest single lever for change. Not everybody in government wants to hear that, because risk management says it worked last time, let's do it that way again. But if government is to say every hospital, every bridge, every airport, every whatever we build from now on must have X as a target, and this is done through modern slavery, this is done through Indigenous employment, this is done in many aspects of procurement. But if they were to specify outcome-based targets rather than input-based targets, they can affect change and allow innovation to get there. I heard a really good example from a terrific member of MECLA, lovely guy from John Holland, one of the big constructors in the market. And he was saying that he's on a road, he's a construction engineer on the ground, dirty boots, hard hat, building roads. And he was working on a government project that said your target is 20% recycled asphalt in the road surface. And he could do 40% and was like, come on, government, let me do no, the contract says 20%. And so it was so specific. And he was like, well, I can do better. There are other examples where some government contracts have said we want 30% SCM, supplementary cementitious materials, to reduce the carbon of the concrete. So instead of Portland cement, they're using fly ash or granulated granulated blast furnace slag, other waste products to reduce, the limestone-based Portland cement. But if they say it has to be 20% or 30%, and there are other things that could be done on that project to reduce carbon more, that can be quite restrictive. And so an outcome-based target rather than input-based target is very important. But the main question there, Loretta, is if government sets the target for a project or a precinct, yes, that has an outcome because of the project or the precinct. But the change up the supply chain, and that's what you were getting to, is really significant. If John Holland says, all right, we're going to build that bridge for that state government or that the federal government, and it's in a particular part of the country, they probably don't have all the boots on the ground, so they're going to subcontract. Now, the subcontractors may not have used those materials or that methodology before, but John Holland knows how to do it. Capability uplift is the jargon, but basically teaching the blokes with boots on the ground how to do it, and the suppliers how to get it, and the quantity surveyors how to measure it, and the engineers how to design it. And I'm deliberately ticking off all of the disciplines that go into making it because it's systems change. And when government leads that systems change, every component along the way has to update. One of the reasons we hear in a concept of economic rationalism of why private sector delivers better than government is that private sector is better at managing risk, better at managing costs. But that can also get in the way of managing change. And so it can take the government as the catalyst to say, no, we want that change. And most of this isn't rocket science anymore. This isn't new. I've already mentioned the Anzac Bridge. That was built when I was a kid getting ready for the Sydney Olympics. That's not a new bridge anymore. And it does use 65% waste industrial product in the pillars, and it happens to be more resilient in a marine environment. I use that example a lot because it's such a major piece of Sydney infrastructure, and it's using this material, and other parts, engineers who haven't come across it, like, I wouldn't take that risk. Well, mate, it's not such a risk. It was done quite some time ago, and all the information's there if you want to find out about how it was done and the longevity of that asset and so on.
And why do you see the industry only now treating proven and resilient materials like the concrete used in the Anzac Bridge as being new or innovative, 20, 30, 40 years after they came to market?
Yeah, I sighed rather than answered the question because it's something that comes up a lot, and we think about it, and we prod and poke at this from different angles to try and really understand what's this about. My working hypothesis is, look, a lot of the different answers for different parts of the value chain, but on the ground, it's someone's ass is on the line. And if some smart aleck sustainability guy, I'm mocking myself there, has specified, we've got to have low emission cement on this project to go into the concrete to blah, 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 blah. And the bloke on the ground knows that, shit, I've never used that material before. And if it goes wrong, my little family business is stuffed. Send that truck back and get the standard stuff. That's a very natural human response to risk. It could be, I don't like the smell of that paint. I've never used that one before. It's not because they're not interested in emissions. It's just because it's different and they haven't used it before. I think that's a very genuine and valid concern for change. So that means we need to communicate and train and normalize these new materials. That's on the ground. For the engineer to sign off on it, a lot of that is education. These men and women are in a profession that they have learned from Roman engineering and every improvement since. This is how you build a viaduct, a bridge, a road. And that best practice is built on what has worked for decades, hundreds of years. Change takes so long in that. Even if it's not an environmental change, it takes time. This standards process is conservative for a very good reason. We're lucky in Australia. Bridges tend not to fall down. Our engineers are conservative for a very good reason, to keep us safe. My point is that the context of their challenge has now got more complicated because we now have climate change as a problem that we all have to solve. And we can no longer just use last century's materials and last century's designs because we're in this century's climate and we have these newer materials and better ways of doing things. So it's not a question of saying, you idiots are wrong. It's a question of saying, hey, that worked then, and here are some solutions that work now. And that's why the story of the Anzac Bridge or any other building or piece of infrastructure that uses the newer materials is a great myth buster to say, well, look, it can be done. And here's the material data sheet, and here's the longitudinal study showing how it's performed, and so on. Change is difficult. People don't like the financial risk of change, the professional risk of change, or the safety risk of change. But the climate risk of not change is what MECLA is all about.
Completely agree. What we hear the most, right, is how can developers justify that additional premium?
The assumption that there is a premium is part of the problem here, because that needn't be the case. And a lot of times there is the assumption that it's low emission, therefore it costs more. I would challenge project proponents to have an open mind to say, well, let's check if it costs more rather than let's assume that it does. Because the scale of production now for instance, Holcim, one of Australia's big cement producers, they're actually French parent company, but very big and active and a real contributor to MECLA. But both Holcim and Boral, they have at scale, low emission, ready mix cement ready to go. And the price premium has come down so much in the 5 years we've been having this conversation inside MECLA that it's, from an overall project cost, it's a small amount. And if you are looking at the costs, again, as a systems thinker, I would say look at the funding, because the super fund who is investing in that asset or in the company that's building that asset, what financed emissions do they want to be responsible for? Do they want to be investing in greener assets and infrastructure? Or do they want to be investing in high emission business as usual infrastructure and assets? There are several levers that change of systems is looking at. The government setting planning requirements or legislating that. The constructor saying, well, what is going to meet my requirements, but also help reduce emissions. The developer with its portfolio and then the financier all have a role to play in driving down those emissions. The selection of the materials is often site specific, because particularly concrete is going to depend on the climate, on the time of year, the weather. There's lots of nuance. There are thousands of mixes of concrete. There's a lot of detail on the ground, but at the high level, there's no reason not to be setting ambitious reduction targets just because of the assumption of cost or the assumption of it's difficult.
One thing I want to add to this question is, does it have any impact on speed? Is choosing low emissions technologies or materials have an impact on the development speed?
Not in the terms of a 100-year asset, and not in the terms of a 12-month build or a 6-month build cycle. A low emission recycled steel delivered to site, absolutely no different working that low emission steel to virgin steel. The concrete, there are different setting times for different mixes, but if we start to prioritize carbon as a success factor, yes, there might be a very small time impact in terms of that part of the delivery, but we're talking maybe a day over a 100-year asset. So I don't think it's a reason not to do it. It's something to be done with eyes open. And, having worked in the development sector for many years, I get the, come on, time is money, but there are lots of other things that take time that we accept. Planning approvals, coming back to change management. The first time a contractor uses that material or a different supplier, it might take longer, but only the first time. And then the second time it'll get easier, and the 10th time it'll be business as usual. So overcoming that challenge is temporary.
That's really interesting, and it makes you think about early adopters as well. They were the ones to take a lot of the commercial risk. Do you have any good learnings from the early adopter stage and how important it was to get the timing right?
Yes. Good question. Sorry, I'm responding with another sigh because it's a big one. Taking on the commercial risk, MECLA with the Smartcrete CRC has recently done a demonstration pour of low emission cement in footpaths on the central coast of New South Wales. And several other local governments came to look because they thought, well, we could use that material in our projects. And it came about because we ran an event looking at the use of low emission concrete in industrial warehouse slabs, the foundation slab. And it was put to us, well, until we've used that material, we don't really want to use it. And it was actually one of the senior managers from Fraser's, the property company, said, well, guys, just go and lay a whole lot of footpaths to get used to that before you use that material in the slabs. So really practical, commercially sound risk management. We've get used to it on something that's not critical and then use it where it is critical. So there are past ways to managing that risk as a first point, but we manage big macro risks when there's an emergency. The fact that we're doing this online and I'm not in a studio is post-COVID normal. Pre-COVID, probably not, guys. And so we have these pivot moments where our priorities change, the technology to enable that change is in place, and several factors come together to enable the change. Timing is crucial, but I'd also say that now that momentum has begun, now that NABERS, the National Australian Building Energy Rating Scheme, that has a carbon tool. You asked about the measurement, Loretto. People are measuring this stuff now. There is less risk in 2026 in acting on this than there was in 2021. And there's less risk than there was in 2015 and so on. And added to that, I mentioned the financiers as one of the levers. Now that we have AASB S2, the Australian Accounting Standard Board S2 legislation for listed companies to report their scopes 1 and 2 emissions and eventually to follow their scope 3 emissions. All of this construction embodied carbon that we're talking about adds up to the scope 3 emissions for the big developers, for government, for the investors, and they need to report on this. And they're reporting on it ultimately to get on a downward trajectory, which means there's even greater incentive and reduced risk to act on it.
Absolutely. And it dovetails so nicely into what is one of the biggest topics of 2026, which is data centers, what their life cycle is going to be. A lot of tech leaders are unaware of the huge environmental footprint that their physical hardware is going to have. So I was wondering, what are some of the findings from MECLA's most recent white paper regarding the carbon intensity of simply building these facilities before the operational pollution kicks in?
Several layers to that question, Dan. I should say we've written that in collaboration with DBI, the Decarbonising Building Industry Research Network, centred at University of Melbourne, but we've brought an industry lens to this piece of research. And you're absolutely right. The global emissions of data centres, construction and operations is now a greater climate impact than global aviation. It's big. And unlike global aviation, we know when we're getting on an airplane, but a lot of people don't know when they're using the cloud or what they're asking their smartphone to do is actually being done in a data centre in Western Sydney or anywhere else in the world using tiny amounts of electricity and tiny amounts of water and embodied carbon per question or per task or per video or selfie or whatever they're doing. But cumulatively, it is massive. This is so out of sight, out of mind. The cloud is this lovely marketing metaphor for absent computing power, and we have to register that. Now, we're no doubt using some of that huge growth in smarts for this conversation. So it's not a question of hypocrisy, it's a question of opening our eyes and understanding what do we really need and what are the impacts and how can we reduce them. This white paper that we worked on was really stakeholder-based to understand what are the hyperscalers, so the drivers of the big data centers, what do they understand about embodied carbon and what are they doing about it? And the numbers are pretty stark. The emissions that go into the materials to build these centers are huge, really big, strong floor space, so slabs, because of where companies want to build the data centers. They're not always just single story. If they're going to be in a congested area, they're multi-story, and multi-story means a lot more embodied carbon per square meter. Just like any other big shed, there's the foundation, there's the structure. But with data centers, there's also a lot in the racks, the actual equipment that goes in, and that adds up because a lot of that equipment is replaced 4 or 5 times in the life cycle of the data center. It's one of those things that you're starting to understand the problem as the problem continues to grow. And so we need to rapidly act on findings so that low emission materials are asked for and emission aware designs are asked for. So
Yeah. And I was thinking of asking you how someone in sustainability could build the business case for their CFO.
Invariably, if a project has a strong carbon focus, it will, as a co-benefit, have a strong data focus, which will give it accuracy and other quality benefits as well. Where there is a focus on carbon measurement and carbon minimization, there are co-benefits that improve the breed. Business case for a sustainability person is strongest when a company is values-driven and value-driven. If they want the best carbon/climate outcome and they want a strong business outcome, you're winning because you can make decisions with that confluence of value and values. If they're only doing it for compliance, the executives are just bloody another thing, more red tape, green tape, just comply. The smart money is saying, well, what can this data tell us? We're collecting all this data. We're having to engage with suppliers. All right, there are relationship benefits. What can we do around efficiency? What can we do around smarter procurement? Yeah, it's complex, but hell, we're adults. We're good at complex systems. And so, yes, there is a business case. If you can make a saving with activity A, hopefully you can cross-subsidize activity B in its initial stages until it can pay for itself as well. Because the first time you do anything, it's going to cost you more than the 100th time you do it. And getting the business as usual efficiencies of scale takes time. Can I be really honest with you guys? One conundrum that I've been mulling over in my head because of a novel that I'm reading by the English author Ian McEwan. He set this novel in 100 years' time after climate calamity. Looking back at the 2015s, 2010s, they were decadent. They'd fly to Rome for a conference and then fly home again. They'd drive 2 tons of metal to go and get 2 litres of milk. How ridiculous. And it just got me thinking that one of the weaknesses of a change management outlook is you start with where the system is at. Now, we don't have a choice in that. We have to talk to constructors about how they build now and how to improve that a little bit. The problem is that doesn't have a focus on the planetary boundaries, which are actually the reason we're doing this. If we really think about the challenge here, and this is probably a philosophical question, the challenge is we're banging up against planetary boundaries that need step changes, not incremental changes. And so in our toolkit as change managers, we think about incremental change because that's less scary, it's manageable, it's less risk, it's less cost, could have a profit, but it's nowhere near addressing the planetary boundary challenge. The penny really dropped when I was talking to a new client also getting ready for this mandatory reporting framework, and their CFO was in the workshop, and he said, well, how about you set us some intensity metrics to measure our progress? And that's a really mainstream, smart question to ask around efficiency. But zero is zero. We were on a net zero pathway plan with this company. And I commented that, okay, that's a useful tool in the interim, but there's no intensity of zero. Zero is absolute. And as sustainability people, we have to be on the journey with our clients, with our companies, with our governments, as we vote, as we purchase, whatever we're doing. But we also have to recognize that it's the planetary boundary that is the reason. That's the hard stop at the end of the line that we are banging into. Keep in mind that that's why we're doing it. And so incremental changes to get the ball rolling, but we've really got to speed up after that.
Yeah, absolutely. Well, Hudson, we're drawing the episode to a close here, and it's been such a fascinating conversation, and we're really grateful that you've shared all these insights. If you had to highlight one key takeaway from the work that you do with MECLA, what would be the one thing you would want everyone to know? And is there a call to action for people in industry?
There is a call to action, and that is to ask the questions about embodied carbon. Are you working on this? What can you do about it? And if the first answer is yes, okay, give me specifics. And not in a challenging way, but in a teasing way to keep it moving. Are we doing it? What are we doing? Could we do more? And one of the key lessons from MECLA is that no doesn't mean never. No, I can't do it now might be the first time somebody's been asked. And then the next time you ask them again, are you doing it yet? What's in the way? And to keep going. Lots of anecdotes from MECLA members where the first time they asked for low emission aluminium in a facade, I know you can't get that. The second time they asked, that's a $15 million premium. And the third time, oh yeah, we've worked out how to do that. And so the call to action is to ask and to keep asking and be really persistent. Keep going. Do your homework, find the myth busting, find the examples, find the case studies, find the allies. But history is on your side, science is on your side, engineering is on your side, material sciences is on your side, momentum is on your side. Europe is really pushing this. The Carbon Leadership Forum in the US is pushing on this. There are green building councils across Asia that are working on this. We're not alone. Keep going.
Unreal. So into the rapid fire. What is a thought-provoking book, podcast, or article that you would like to share with our listener?
Anything where Christiana Figueres is interviewed. She was the Costa Rican diplomat who led the Paris Agreement. She talks about stubborn optimism. Anytime I hear her speak, I think, all right, keep going. Because look, there are days when I think, we are so screwed. I don't know why I bother. And then I hear her stubborn optimism, keep going. That's my mantra. Anything which she has written or spoken to, Outrage and Optimism is her podcast. She's my go-to.
Yes, we are big fans here on The Green Fix. So Who is someone that inspires you that you think we should interview here on the Green Fix podcast?
Nathan Fabian. I've known him my whole career. He was actually my senior when I was a junior at Arthur Andersen, the defunct professional services company. He later in career became the CEO of the investor group on climate change, and he's now one of the executives of the PRI, Principles for Responsible Investment. He's an Aussie with an international view and really gets climate at a policy and institutional and an investment level. And he's a wonderful human being. So yeah, get him.
Awesome. Thanks. Can you share a piece of positive climate news that you've heard recently?
It's policy, not science, but the release of the National Climate Risk Assessment, looking at physical risks, is a fantastic piece of work. It doesn't look at transition risk, but it's long, it's layered. I do a lot of work in climate risk assessment, and it's done so much of the broad brush groundwork now that it will accelerate anybody who's wanting to do climate risk work can start there. And it is, some of the critics called it alarmist. To me, a lot of it, what it says is alarming, but not surprising. It's good news that is now accessible to all of us.
And final question, if we gave you a magic wand to change one thing in the world, what would you do with it?
I would love to see a high global price on carbon. It would be so powerful in pricing what we don't want, pricing, the ultimate in climate externalities, and so many other parts of systems would then fall into place because of that. I'd say global because then we wouldn't need carbon border adjustment mechanisms and other complexities in the trading system. But I do think that would work right at the moment when there's a war blazing in the Middle East. It's hard to be selfish as a greenie and say, I want a climate solution with my one wish. But I also know that if we took the value away from oil-based energy solutions, some of those problems would probably also fade away. Yeah, that's my wish, a global carbon price and a high one.
Very good. Hudson, thank you so much for joining us today. The insights that you have, the collaborative approach that you take at MECLA, the work that you do at Precinct, that's so important. And we are very appreciative that you joined us today on The Green Fix.
Thanks, Dan. Thanks, Leroy. Look, the reality is this is too complex for any one of us to do it on our own. We have to collaborate or we're not going to win. It's as simple as that. Thanks, guys.
Absolutely right. Thanks, Hudson.
This was Green Fix with your hosts, Loretta Gutierrez and Dan Levington. You can get your Green Fix every 2 weeks on Apple Podcasts, Spotify, or Pocket Casts.